Hello, girls. I hope you are well. Hope you are enjoying this beautiful sunshine. I wanted to look at our new system. This is just a short video, and we're just getting started. But we're looking at defense, which is really often called the immune system, right? And we're going to first kind of do an outline to look at the different types. Innate means inborn, non-specific means just that, not specific to a type of pathogen. And instead, there's adaptive, which is something we're not born with, but we adapt to, such as when we get a sickness and we get an immunity to it. And specific means it's for a specific type of pathogen. Okay, so these are the two general categories. Within this innate and non-specific, there's a first and second line of defense. So just take a moment to read these, and then we're going to go over them. Okay, this is the exact same chart shown differently. This one might be more clear. So this represents the big physical barrier we have all over our body that acts like a wall, like a physical wall keeping pathogens out, which is, of course, our skin, right? And this represents pathogens bouncing off because they're not able to get in. And that's our biggest immune defense on the first level. And then this is showing within the body. These are phagocytes, these are macrophages, and so on. And then here is the lymphocytes and the antibodies. So this shows the three lines of defense. And notice how the first two are inborn. You don't have to adapt to them. You just have them as soon as you're born. You've got phagocytic cells, and you've got skin, and you've got mucous membranes, and so on. And they're non-specific. They attack everything foreign, every invader. Sometimes they'll even attack things that are not bad, like dust or pollen. Okay. And well, obviously, in contrast, this is specific to pathogens, and this is an adaptation that we develop to something bad that comes into our body. Okay, so this and this are really the same thing. One of the questions is to kind of write those out and just go ahead and pause and look at them and make sure you understand. Excuse me. Okay, so first line of defense is really simple. Skin, which is the big wall, the big physical barrier. There are also some chemical barriers built into this first line of defense, which are really cool. A lot of our skin secretions are hostile to bacteria. Either they have the wrong pH, which discourages many bacteria, or they even have enzymes which kill off bacteria. That is also true of our saliva and tears, which contain those specific enzymes. And then obviously the other secretions, digestive secretions, are really hostile to bacteria with the acid and the digestive enzymes. Okay, so that is the first part of the first line of defense. First line of defense continues when you go to every opening within our body that is open to the outside. So these are all in the respiratory, digestive, reproductive, and urinary tracts. And you know this well, that they're all lined with mucous membranes. And I'm sure you remember why that is an immune or a defensive response, because the sticky mucus traps pathogens, right? And then usually finds a way to get them out, to help them to flow out. There's two little traits that the respiratory and digestive system have additionally. Respiratory system has cilia. So remember how this is a really weird picture. The cilia almost look like hair, but the cilia are always sweeping up in this direction, sweeping upwards to push mucus out, and to push mucus up here so that it gets swallowed and goes to the stomach. The stomach has that additional trait that we talked about a moment ago, hydrochloric acid and enzymes. Okay, but so the walls on the most basic level are the skin on the outside and the mucous membranes, which is not internal to the body, but you could say it's the internal openings. It's the openings of the body which are open to the exterior. Okay, now we get to the second line of defense, which means the pathogens have somehow gotten through. They've gotten through the skin, gotten through the mucous membranes. They're inside of our tissues. And so something else needs to happen. And the first thing is, again, familiar, phagocytosis. Neutrophils and macrophages, some of them are found in the area, some of them rush to the area, and they do their wonderful phagocytosis, the Pac-Man stuff. This is a new picture from the ones I've used in the past, but it's the same thing. The red thing is the bad guy. The phagocytic cell is this yellowish cell. It engulfs it and fuses with lysozymes and digests it. Okay. Fever is also response of defense. As you know, we're not going to talk about it a lot, and it's actually talked about very little in general. I don't know why. Fever, it comes from the fact that elevated temperatures greatly discourage the proliferation, the reproduction of pathogens. So fever is a good thing, although it's talked about very little. I don't know why. Maybe it's really not that important. In fact, what's the main thing we do with fever? We take medicines to bring down our fever. So we don't seem to take that as a very important step. I've always wondered, I've always wanted to study that more and understand why. All right, the third thing is the inflammatory response, and that is a big deal. The inflammatory response, let's just go over it. The really basic things, look at the blood vessel size. What happened? The blood vessel got bigger. It's the dilation of a blood vessel, which increases blood flow. That actually nourishes the tissue to help it heal, gives it plenty of nutrients and oxygen. It increases white blood cells. We'll talk about this in a minute. Increase in blood flow, increase in white blood cells, increase in blood vessel permeability. Let's just look at that really quickly. When the blood vessel dilates, here's a normal blood vessel, a dilated blood vessel. The gaps between the cells get bigger. So the blood vessel is more permeable, which means things can get in and out more easily. Okay, so this is really important. Capillaries dilate, and it leads to these three increases, which should be logical, which should make sense. So what's the result? More white blood cells and fluids leave the capillary and go to the tissue of the injured site. The white blood cells cause phagocytosis right at the site of injury. The fluids cause swelling, and eventually they will start to clot. They cause clotting. Okay, so this is the whole inflammatory response. It's all triggered by this chemical called histamine. Histamine is one of the things released by granulocytes. Remember, granulocytes was one of those white blood cells with cool little vesicles of chemicals. So that's what begins the entire inflammatory response. If your inflammation gets too great, then people sometimes take antihistamines, in other words, to calm down inflammation. Okay, so this picture shows what? The blood vessel dilating, the extra white blood vessels arriving and then leaving the blood vessel and then performing phagocytosis. These orange ones are the bacteria, so they're eating up all the bacteria. And then, of course, the swelling of tissue, which you can't see it, but that swelling will cause clotting. Okay, let's just look at it more. So the terms are vasoconstriction, when a blood vessel is narrowed in diameter, vasodilation, when a blood vessel is increased in diameter. And vasodilation occurs as a first step of inflammation. This shows how the vasodilation makes these gaps between the cells larger and stuff gets out. Fluids get out, white blood cells get out, even a little bit of red blood cells, all kinds of things get out, which makes the area swollen and red and full of white blood cells. Okay. All right, this is just a picture to show the increased permeability. So here the cells were tight, now there's more space between the cells. And what are the white cells, blood cells doing? These are neutrophils. Remember, they're the most important white blood cell. They're squeezing out and entering the surrounding tissues. Okay, and this is just in case, in case this picture helps you, it's another way of looking at inflammation and looking at the four famous symptoms. I don't know why that keeps popping up. The four famous symptoms. Oh my gosh. Heat, redness, swelling. I consider pain and tenderness the same thing. I don't know why they put it separately. So you see all that. Remember that leukocytes is another name for white blood cells. So anyway, you can pause this and look at it if it helps you. And okay, here's one last aspect that's just kind of unusual. Chemotaxis is this really crazy thing that happens. It's a chemical signaling, a chemical calling. So at the site of injury, some of your white blood cells release chemoattractants, chemicals which attract white blood cells. The chemoattractants enter the bloodstream and flow everywhere. So they get around to all the nearby tissues, and it's basically an alarm saying, we're in trouble, we need you, we're in trouble, we need you. It's like some kind of huge fire has occurred, and all the nearby fire stations have been alerted and are signaling all the firemen and fire trucks to come to this area. And so chemotaxis is this way that phagocytes are literally called through the bloodstream to the area of injury. I don't know if this picture helps very much. It shows that the chemoattractant, the chemical, increases in concentration at the site of injury. This is the site of injury. The concentration is highest here. The white blood cells know how to follow that concentration. So if this is confusing, just get the basic idea. I've got another picture on it, actually. Okay, here's the other picture. Here's a white blood cell, macrophage. It's releasing, you don't have to know the names, but they're cytokines, this chemical which signal the white blood cells and signal the path how to get there. These cytokines go in the bloodstream. They also go in the surrounding tissues. And they travel, say, calling out the alarm, come, come, we're in trouble, right? Notice over here there's a wound and bacteria have entered. That's why they're in trouble. And the neutrophils will, and other white blood cells will hear that alarm, will travel to the area of infection and exit the area of infection and come help. Here's a neutrophil ingesting some bacteria. Okay, you know what? Let me look at this picture one more time. This is more thorough. This is the big picture. So these two white blood cells, the green one we didn't learn about, there's lots of white blood cells we didn't learn about, the green one, the purple one, release chemicals, which are chemotaxis, a calling out to white blood cells. White blood cells respond, exit the blood vessels, and come to the rescue. They've been called or signaled to the area. Okay, this is a little summary I made. So once the inflammatory response has been released by histamine, there's vasodilation, increased capillary permeability, and chemotaxis, a calling out, a signaling to all the white blood cells and leading them to the injury. Okay, so one last comment is about fluids, because it's kind of confusing. Inflammation is really weird. It causes an increase in blood flow and in fluid flow first, an increase in blood and an increase in fluid leaking out, right? That makes sense. So there's more blood coming and there's more fluid leaking out, and that's what causes swelling. That's the first response. But very soon after, because there's so much extra blood and other fluids, it starts to clog and clot. So clotting is actually the secondary result of lots of fluids, and that's really important because it cuts off the flow of fluids so that the bacteria stays contained. It's like a way of blocking off the bacteria. So notice that increase in fluids causes swelling, but eventually it's going to cause clotting, which closes off the area of infection. You might not think of that as important because infection doesn't affect us that much usually, but think of the old days when soldiers would get an infection and it would spread and their leg would have to be cut off, right? So the fact that inflammation is cutting off infections is really important. Okay, that's the end. Let me make sure I covered everything. Yes, this is just another picture of the same old stuff. Then this is a summary, once again, of what we covered. So we did all of innate or non-specific immunity, and you have questions to work on for those. All right, girls, take care. I hope you have a good day.